3 and 1c as well?
Yep.
Okay.
Newton's method. And then I'll come back to this section that is bigger because it has different applications, many different applications. Newton's method. Now, do you remember that when we talked about the intermediate value theorem, it was for a continuous function that changes sign on an interval, so closed interval a comma b, where f of a, let's say it's positive, or f of b is less than 0, or vice versa. And our conclusion was from here that there exists a c. There exists a c in the open interval a comma b such that f of c is 0. So this was a long time ago in chapter 2. Okay, we're going to use this again. Now, what are we trying to do here? And Newton was brilliant when he came up with this. He said this. Here's a function. Obviously, there is a solution here, an x-intercept if you want, or a 0 of the function. Let's call it r. R is the root or solution to f of x equals 0. Or all these mean the same thing. Or x-intercept. And the target is to find r. Find r. Let's say with 8 decimal digits. Approximation. Of course, we're not talking here about a linear function. We're not talking here about an equation that can be solved algebraically. Of course not. We're talking about something like, and I'm going to copy an example, and eventually we'll get to it, like this. Sine x equals x squared minus 2. This is our equation, and we want to solve it. And no one can solve this algebraically. There is no way of solving this algebraically. Okay, so how do I find this solution? So let's say r is the solution of this equation. First, I would like you to understand that we have to find an interval. The IVT gives us an interval where the solution exists. It doesn't tell us what it is, as we discussed a long time ago. The intermediate value theorem does not find C. But the intermediate value theorem is giving us an interval. And we prefer always a unit interval. Unit interval. A unit interval is, for example, between 1 and 2, between 9 and 10, between 10 and 11. Not between 1 and 10. This is not a unit interval. So assuming, can you go even lower? Yes, but not more than 1 unit. So it's recommended. So let's suppose I already have that interval. So let's say we know that the function has a solution between, let's say, this number a and this number b, and this is a unit interval. My first step is choosing a starting point, either a or b. That is denoted by x sub 0. Some people call it x naught. So it could be a or it could be b. It doesn't matter. So we will call this the starting point, and from here we will want to go sequentially through an iteration process. What is an iteration process? It's getting closer and closer and closer and closer. That's an iteration process as an example. Okay, so what did Newton say? He said this: start anywhere you want. There is a problem. I will come back to how we choose this because there are two restrictions for this. Okay, so two potential problems with x sub 0. I will come back to them in a minute, or two or three. I will not forget. So let's assume the conditions are fulfilled, and I will give you the two conditions. And let's suppose I start at this point. I'm going to zoom in here, take this piece on the next page, because it's too close. So this is the interval a comma b. Here's the graph of the function. And this is the solution that I'm looking for. And this is the r. I don't want to be too close because I need space. Assuming that this is my x0, x sub 0, I start at b. I will draw a vertical line and create a point here. No, it's not P and Q, it's just, let's call it point 1. And at this point, I will draw a tangent to the graph of, I do have a ruler, but I don't want to waste your time. I don't want to waste your time and look for it, but I would really like to have it. So I'm drawing a tangent here to the graph of f of x. And here's the tangent. And the tangent at that point, at point 1, will cross the x-axis at this point. I'm going to call this point point number 2. Before I get any further, I would like to identify the coordinates of this point. Can anyone give us the coordinates of this point? Yes, the x has to be x0 or x sub naught, sub 0 or x naught. But what is the coordinate of, what is the y coordinate of point 1?
F of x.
Oh, of course, f of x0. Good. Now, write this here, this point, point 2. Can anyone give us the coordinates of point 2? And I'm going to give you x. The x at this point is called x sub 1. X sub 1 is the first iteration. But I would like you to give me the y coordinate of point 2.
0.
Of course. Thank you very much. It's on the x-axis. Good. So what have we accomplished is this. We started with an initial value. Of course, x sub naught or x sub 0 is not the root. It's not. But it's close because this is a unit interval. So I start here, and my target is now to determine this point, determine x1. Why? Because x sub 0 is far away from r, but obviously x2 is a better approximation of r than and x sub 0 is. Look at the distance. So I will say that x1 will be the first approximation or the first iteration towards getting closer to r. Okay, so I have this line, and I can determine the slope of that line. I have the coordinates of both points. When I have 2 points, I can determine the equation, the slope of the line passing through them. Can anyone tell us the slope of this, how to write the slope of this line? y2 minus y1 over x2 minus x1. So f of x0 minus 0 over x0, x sub 0 minus x sub 1. But I know that this also can be presented in a different way, and we've done that some time ago. Is there any other way of presenting the slope of this line? So I don't want you to think in terms of the distance, rise over run anymore. Can anyone give us the slope of this line that connects point 1 to point 2?
Difference question.
I really hope that this is very clear. I'm really hoping that by now, in 2 months, this is clear why the slope of this line is f prime of x0. So that's my hope. Any questions on this? Okay, what do you think I'm going to solve this equation for again?
Solve the equation for x0.
I already have it. I started with it. I chose it from the very beginning. That's my choice. It's known. So, okay, one more time. I started with x sub 0. It's not the best approximation. I got to point 2. Point 2 is a much better approximation of r.
So you would solve for x sub 1.
Exactly. X sub 1 is my target because x sub 1 is a much better approximation of the actual root or x-intercept or 0 of the function than x sub 0 is. Perfect. Thank you. Good. I'll cross multiply. So I have f of x0 equals f prime of x0 times x0 minus x1. I will divide by f prime. F of x0 over f prime of x sub 0 equals x0 minus x1. I will move x1 and I will move this because I don't want to have to multiply by -1 anymore. So it's this. So with this relationship, now you understand why this is an application of differentiation. With this relationship, I found a better approximation of the root r than the value I started with. Okay. Stay with me. I have one more step here. I continue the process. And here's what I do. I draw a vertical line. I create point 3. Can anyone give us the coordinates of point 3?
Would be x sub 2 negative.
We have not discussed any
negative
x sub
0.
we have not discussed any x sub 2. It's on the vertical. Very good. It's on the vertical axis, on the vertical from x sub 1, and then
f of x sub 1.
f of x sub 1. Excellent. Of course, what I'm going to do, you already know. I'm going to draw a tangent to the graph of f of x at this point, point 3. And of course, it will meet the x-axis in point number 4. Now I'm giving you the x of point number 4. Of course, it is x sub 2. And please give me the y coordinate of that point.
0.
Excellent. So now what do you think? Among these three, I know it's a silly question. My apologies. X sub 0, X sub 1, or X sub 2, which of these three is a better approximation of the actual root r?
X sub 2.
Of course. Okay, so in the same way, can you just look at this relationship and tell me how much is x sub 2. Careful, because now the tangent is between x sub 1 f of x1 and x sub 2 comma 0. So what do you think x sub 2 will be? In the same way, I will write the exact same relationship. So what do you think? Your guess.
Would you replace the sub-zeros with sub-ones?
Exactly, x sub
X
1.
sub-ones.
Very good. Because it depends on x1. Can anyone give us x sub 3?
Same thing with 2.
Thank you. In general, x sub n plus first equals the previous one minus f of the previous one over f prime of the previous one. And this is Newton's method. That's what he did. He drew tangents and tangents and closer and closer and closer and closer and closer. So these are the iterations. First, second, third, n plus first iteration. I will stop when I achieve the number of decimal digits I want. If I show you when. If I achieved 8, I'll stop. It may converge. We say normally it converges. The method converges in few steps. By few steps, I mean 3, 4, 5 at the most, depending where you start. Before we look at our example that I picked, the sine x equals x squared minus 2, I have to come back here. What could be the problem or problems? Here's one. F prime of x0 is undefined. If I choose a starting value that makes f prime undefined, I will never find anything. I will get an error from the first step. I will not be able to find the first iteration. So I have to be super careful here. Okay. Second problem. So that's one problem. There are two problems, potential problems. So be careful. Find f prime. And when you decide this or this, make sure that what you choose does not make f prime of x sub 0 undefined or 0. So if this is undefined or if this is 0, you will not even find the first iteration, let alone the rest. Here's the second potential problem. If I start here and the function happens to have a max or a min between the starting point and the solution I want to find, the method will stay here and will never converge to this. I'm going to write this down for you. Make sure that there is no max min between the starting point, the initial value that you start with, and the actual solution, because you will never get here. Okay? So, potential problems. With the choice of x sub 0. 1, f prime of x0 undefined. I can put it separate, it doesn't really matter. F prime of x0 equals 0, that's another problem. And number 3, a max or min between x sub 0 and the actual solution R. So these are the potential problems. The method will not converge. You're not going to be able to get anything. And that's it about Newton's method, but I need to show you a few examples. You can choose any example you want. I chose this one first. So sine x equals x squared minus 2. Find a solution. So if your web assignment says find all solutions, I don't care. Let me know and I'll give you the credit. I only want one. If you know how to solve one, if you determine one, it's good enough. I need to